Well, hello again everybody. Anybody know what we're going to be looking at today? Well, you've probably got a bit of a clue because it's in this box. And it's got a distinctive automotive theme to it. Okay, so what I've got to look at today is this. It's an MSD6AL, and it's a multiple spark discharge electronic ignition system. Now some of these bits that have come with it we don't really need, so I'll just move them. So this is the main unit, and as I just said, it's an electronic ignition system, and what it does is it's designed to produce a very, very high powered spark. And it's really designed for things like racing engines and stuff like that, you know, in dragsters and performance cars and things of that nature, where they tend to be running at very, very high RPMs with rather strange fuel mixtures or variations in compression, where they need a lot more spark than you would get from a conventional ignition. Now, I remember back in the day, you used to be able to get these little electronic ignition modules that you would plug into your Austin Allegro, and I think one was made by Lum, and I don't know if the one was called Spark Right. Basically, they had a big transistor in them, and they all they really did is, rather than your points and your distributor switching on and off, they would actually use a power transistor to switch the power on and off to your coil. Now, and it isn't a contraceptive. Now, I expect if there's any younger viewers watching, which I'm sure I haven't because I'm too boring, but if I have got any younger viewers watching, you probably haven't seen these separate coil packs because you're probably used to having these fully integrated electronic ignitions in your car where you can't, you know, you basically can't even see the engines for plastic covers. But before that, everybody used to spend most of their available free time and weekends playing with distributors and points and condensers and plug leads. You had to do that basically the entirety of the weekend so that you could actually go to work on Monday morning in your car, because after a week's driving round it was knackered. Anyway, so what they used to do is people used to try to put these electronic ignition systems on and to get an improved, more powerful spark, which in theory would give you better fuel economy and make your engine run better, give you more power. Now, back in the day, all cars had a distributor on them, and you would within the distributor you'd have a set of mechanical points, and basically all they were was a switch, and the switch would open and close like that as your engine would rotate, as the cylinders were going up and down. These points would open and close like that, and they would put 12 volts onto this coil, and then you would have a lead coming out of your coil going back to your distributor, and then you would have lots of separate leads going to all your spark plugs and things like that. But what I'm explaining quite badly is that the electronic ignitions of the day, all they actually did was just switch 12 volts on and off. This one is actually quite different and in some ways quite frightening. The way that these work is that they actually have a transformer in them, and it generates about 400 volts DC, and then at a critical moment, rather than supplying your coil with 12 volts, it actually supplies it with 400 volts. So as you can imagine, there's a little bit of difference there between 12 and 400. And yeah, I mean, the main reason it supplies it with such a high voltage, it's actually to do with the rate of change, because the quicker the rate of change we get across the coil, the more powerful spark you will get out of it. So if you go from 0 to 400 volts as opposed to from 0 to 12 volts, if you do it in the same amount of time, you're going to get a more powerful spark out of this end. So that's what this does, and it's also what they call multiple spark. So rather than just giving one fire every time your cylinder reaches top dead centre and your spark plug would normally crack and flash, well, they would not, under a normal set of points, I can't remember whether the points open or close, but basically you would just get one spark. But because this is a multiple discharge unit, what it actually does is it keeps that spark going, it extends it, and again, it just makes sure that all the fuel is actually burnt up. It makes it burn as efficiently as possible. It really ignites it powerfully. So that's what this is. Now these are installed in in racing cars and things like that, and hot rods and all kinds of things, and it's fair to say that they live a pretty hard life. Anybody who's done any kind of automotive electronics will know what a hard environment it is for electronic equipment. So basically you've got a lot of high voltage components in here, which is, always prone to failure. This thing uses a lot of current. It's fused at 15 amps, so you've got a lot of current as well as potential voltage. Within the engine bay you've got high temperatures, you've got a lot of humidity potentially from driving through puddles and stuff like that. You've got extremes of temperature, going from a cold day, maybe -10 when you come out on a cold day, to, I don't know, or maybe plus 100 degrees when everything's really hot in the engine bay. You've got all the vibration and the pounding, and also you've got idiots who connect them up the wrong way around, which is probably the main reason that they destroy themselves. But it's fair to say that, basically these just periodically explode. Anybody who's had this type of ignition system will have probably had a pile of them and bin them. You can send them back to America where they will repair them, and there's a rather expensive fixed repair cost, which really just consists of them generally just changing the fuse down there. Oh, that's what the legend says. They just change the fuse and ship it back to you. But there's a lot to go wrong in them, and what we're going to do is we're going to have a go at repairing this one. So I think the first thing to do is, we need to get out of its box, don't we? Okay. So we will need to do that. Wonder what that is. Got no idea. Okay, let's undo some screws. Got absolutely no idea what that is. Got no idea. Somebody will have to tell me. It really appears to do absolutely nothing. Has some wires coming into it, but they immediately just loop round and come back out again. Got absolutely no idea what that's about. So you can see that inside here everything's very generously coated in a conformal coating, which is just basically varnish. So we've got some power transistors at this end, and again I've been doing a little bit of googling on the way that these work. Is that basically you've got this transformer here which is working as just a basic step-up transformer. So we've got a step-up transformer, and that's this transformer. It's having its primaries switched, and there's a couple of primaries on it. I think they're being switched by these two big power transistors. There's one there and one there. Hopefully you can see them. These power transistors here. So these power transistors, they're switching on and off the primary coil, and they're working as a basic inverter. And looking at the circuit, it looks like this transformer's got a couple of feedback windings in it, which are connected back to the bases of these transformers. So it's kind of that classic self-oscillating transformer circuit. I'm not exactly sure what they call that, but basically the transformer is self-resonant. Well, it becomes resonant with these two transistors here, and basically the coil, the primary supply, will get rapidly switched on and off. So you'll also get a stepped up version of the input. You get a stepped up version of the output, and that gets smoothed, and I'm guessing it's by this capacitor here, which I'm just looking at it. It's a 400 volt capacitor, 600 volts DC, 400 volt AC. So I'm guessing this is the main smoothing cap here, and then there must be, and I'm not sure which one it is, maybe it's that one down there. There must be some high voltage switching transistors in here. There's maybe that one down there, or maybe it's that one. And what they do is they actually switch that 400 volts that we developed across this capacitor. So it charges up the capacitor to 400 volts, and then it discharges it into this coil pack. feel loose. No, doesn't feel loose yet. So I think we're going to have to get this transformer out. I've undone most of the screws, but it doesn't seem to want to come out. I'm wondering if it's being held on by. Yeah, I suspect it might be. We've got a couple of more power transistors down here. I don't know. I wonder if they're screwed into the aluminium. I'm really not sure. Everything seems to use these little torque screws. Everything's anti-tamper. I guess they want to keep the average motor mechanic out because, well, I'm not going to say the average motor mechanic can't repair it, because I'm sure some people do, but I guess they don't want people playing with stuff unnecessarily. Is it loose? No. I think the transformer's going to have to come out, isn't it? We've got some long screws there. Okay, well, I'm not sure what's holding it down now. Could be that last power transistor down there is holding it in. Certainly not very generous with the amount of cabling they give you in here. Yeah, everything's really ridiculously tight, and I am worried about pulling one of these wires off. This has got those, I don't know what you call them, but those kind of plastic grommet wire clamps that I always find them really difficult to get on and off. I don't know if there's a particular way of doing them, but they just feel ridiculously tight then. Kind of amazes me that this thing was ever put together. Everything is just so ridiculously tight. I wonder if I can just jam this open a little bit more. God, that was horrible. That was absolutely horrible. I think this one is that's the primary feed wire to it. I think this black one is the ground. It's clearly been extended by somebody at some point. I wonder if we could put a new wire on there. These wires are, well, I think one of them goes to the ignition. I'm not sure about the white wire. And I think these two wires here, this orange and the black, I think they go to the original set of points on the distributor, and they send the you know, the signal to initiate the spark. I think that's what that is. Oh, can you see what I can see? Probably not. There's a transistor there, which is I can't read it. It's a TIP, but basically it's all burnt. And well, where's Wally? Half of it's missing. So yeah, that didn't do very well, did it? So half my transistor is missing. So yeah, that's not going to fly. Is it going to come out now? Okay, so this has been potted in a huge amount of conformal coating, so they really didn't want this thing, you know, to get water ingress, did they? Which probably means it will be an absolute swine to work on. Okay, I think we'll try and unsolder some of these wires just to give us better access. Oh, and it's one of them where they've wrapped the wire around the connector. That's always annoying, isn't it? Right, I'm not going to disconnect them because I haven't got any crimps to put them back with, so they're going to have to stay on. But I've got enough room to I've got enough room to do some damage now, haven't I? Okay, well I think before I do any more, I'm going to wipe some of this white silicon smegma off these transistors, because otherwise it's going to be all over me and the cat and, you know, the rest of the house. Oh, it's quite hot in here. I'm getting high off that acetone. It really stinks. Right, okay, so what have we got? Well, these power transistors have got to come out for a start, haven't they? I mean, one's got half of itself missing, which you might have to see better now. So half of that transistor's missing, so that's never going to work, and well, we don't know about the condition of the other one. Okay, I can see a resistor down here which looks as though it's broken in half, and I think that resistor over there might have broken in half as well. Yeah, so something rather catastrophic's gone wrong with this, let's call it this primary excitation stage. It's yeah, it's definitely let the magic smoke out. Actually, that seemed to work for once. I've got to admit the big tips work fine on here, but it's the smaller tips that it struggles with. And I think it's not the hand pins that's at fault. I think it's actually the, you know, the vacuum pump is just not adequate. Oh, I think it might have done that. Come on, let's have a little wiggle. Wiggle, 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 wiggle. Wiggle, wiggle, come on, wiggle, wiggle. I think it's just held in by conformal smoke. Oh, I've got white jism all over my fingers now. Oh well, used to it. Well, I think what's called for here is a combination of cunning, acetone and extreme violence. Well, I've got a little bit of the conformal coating off, but I've got to admit most of it's still there. What I might do is try putting some conformal coating in a narrow tray and putting the board in it. Just sitting this bottom edge of the board in the acetone and just see if it'll soften it enough for me to scrape off. Because I don't think the acetone will touch the GRP, but I think it will. Well, obviously it is dissolving the conformal coating because it is going sticky, but it's yeah, it's still quite hard to remove. What I think we might do next is we might just check these transistors. I mean, obviously one of them definitely isn't going to work because it's got a hole in it. But let's just check this tip. It says it's a tip 36. This, don't know what that is off the top of my head. Again, if I was to guess, I would say some kind of maybe a Darlington power transistor of, I don't know, probably maybe MPN, don't know. No component found. Is that because it's got conformal coating on the leads? It's possible. Let's move these around a bit. Another go. No, I think this transistor is dead. And just for a laugh, let's try this one that's got a big lump out of it. Sure, this is going to come up no component found. Red and green shorted together. So yeah, this transistor's gone short circuit internally and puked its guts up. Now, as well as the transistors that have died, I can also see some very fried looking resistors down here. In fact, this one is so fried it's broken in half. And I actually think the other one might have broken in half as well, so I think we could do with getting them out and having a look. You see that one? That one's broken in half, and I think that one's got a crack right through it, and that might be broken in half as well. I'm not dead sure, I think it is. Let's see if we can get a measurement off them. Don't think I'm getting a good connection, as I keep saying, there's just that much conformal coating on everything. So that one's showing open circuit. I think I've got it on the right wires. That one's showing 20 ohms. But that might not be the resistor I'm measuring. It could be something else. So I think we could do with I could do with not dropping my voltmeter on the floor. That would have been better. Okay, let's try getting these resistors sucked off. Aren't they the lucky ones? Kind of thinking that whatever value, I think this might be the same value of resistor here, and just struggling to see what that is. It could be orange, it could be yellow, it could be a really crappy brown colour. I don't know what colour that is. Let's see what that one is. This one isn't burnt, so and I've got a feeling it might be the same value. That'll go on there. Now that's coming up 0.4 ohms, but I think what I'm seeing there, I think I'm actually seeing the transformer. I think I'm seeing the transformer winding there, because there's a transformer winding on either side of it. So I think we might have to just lift that out. Okay, 10 ohms, so it must have been brown. 10 ohms. Okay, well I'm kind of thinking that this resistor that I'm holding here in my hand that I pulled out, I'm kind of thinking that looks like it's got the same top colour band as the other one. So that colour must be brown. I don't know, it almost looks a little bit like yellowy violet to me, but you know, when resistors have been overheated and just when they get old, they can be anything sometimes. Yeah, maybe you're better at reading these colours than I am, but I couldn't work out what it was. because the leg's just fallen off it. Oh well. Yeah, okay, got one with a... Well, we've just got another 10 ohm resistor to put in there then. Right, lovely jubbler. Well, I don't know about you, but that seems like a fairly logical place to stop, doesn't it? So until next time, thanks for watching, bye bye for now.